So I'm going to be teaching you what refractive index is and using it to explain how these water reveal pads work. So each page in this book is a black and white image, and it comes with this pen that you can fill with water, and it has paintbrush bristles on the tip. When I paint with it, colors underneath the white are revealed. So how does this work? When you hear that the speed of light is 2.99 times 10 to the 8th meters per second, that's the speed of light in a vacuum. Light is fastest in a vacuum. The speed of light is slower when it passes through some material. Refractive index is a property of a material that describes how much slower light travels through it and describes the angle of light change when it enters the material. So when light enters a material, it slows down. The refractive index quantifies this reduction in speed. So for example, if a material has a refractive index of 2, light travels through it at half the speed that it travels in a vacuum. The refractive index of a material is defined as the speed of light in a vacuum divided by the speed of light in that material. These values are always greater than 1. For example, water has a refractive index of 1.33. So the speed of light through water is calculated as 2.99 times 10 to the 8th meters per second divided by 1.33, which is 2.25 times 10 to the 8th meters per second. The refractive index of air is around 1.0003 at sea level under standard conditions, so the speed of light in a vacuum and in the air are similar. In terms of refraction, the refractive index also determines how much light bends or changes direction when it enters a material at an angle. This bending of light is described by Snell's law. Snell's law explains why, when you're looking through water, it can be confusing to figure out where an object is located. In these water reveal pads, there's a full color image that's covered by a porous, high refractive index material. There's a spot here where the polymer is scratched off and you can see the colors underneath. Because this coating has a high refractive index, angles of light change significantly when they enter the material. Because it's porous, when it's dry, there are lots and lots of boundaries between the polymer and air, so there are lots and lots of places where the angle of light changes. It's essentially blurring the image so much that you can't see the colors. Based on a patent that's describing not these water reveal pads specifically, but what seems to be similar technology with industrial applications, the coating can be made from an assortment of polymers, the names of which all really roll off the tongue. What these polymers have in common, first, is that they are all PFAS, or per- and polyfluoroalkyl substances, which are the forever chemicals that are not very good news. But they also all have refractive indices that are similar to that of water. This means that when water fills the pores, all of those refractive index boundaries are between two substances with similar refractive indices, meaning that the image is much less blurred and the colors are revealed. Did you know that you could have watched this video a few days ago through Patreon? That's right, I just started a Patreon. I would be most honored if you would check it out. Thanks for watching Chemistry in a Nutshell. If you feel that I've earned it, please like this video and subscribe to my channel.